this video, I'm going to be programming an FM bass patch on my DX11. I'm going to go through all the decisions I make for all the parameter values, all the low-level details, all the nitty-gritty, and I'm going to spend a reasonable amount of time pre-planning everything here on the whiteboard. So I suggest that you grab your favorite beverage and sit back and relax. Tea. FM synthesizer programming isn't really like traditional analog synthesizer programming. If you just jump in and start playing around with parameter values, you're probably going to hit a roadblock. Even if you have a lot of experience with FM synthesizers, you're probably not going to get the results you're looking for. With FM, it really helps to do a lot of pre-planning. I have an approach that has 5 steps to it, and I'll go through the steps very quickly, and then on the whiteboard, I'll go through each one of them in detail. The first step is to split your sound up into layers. The second step is to pick your algorithms and operators. The third step is to choose all the parameters for the envelopes that do the modulation. The fourth step is to look at the feedback loops in your algorithm. And the fifth step is just fine-tuning to bring your sound into focus. I like to think of the sound that I'm programming like it's made up of multiple layers, like multiple samples, all being played in parallel at the same time. So with a bass sound, usually the beginning is some sort of a percussive pop or a chiff, you know, like with a bass guitar. If you strike the string with your thumb, there's that initial like popping attack sound. So I'll just call the first layer just pop. After that original pop or chiff sound, there's usually a quickly resonating, decaying part where you get the loud sound and then it quickly decays down to kind of a nominal level. So I'll just call that the resonant part right after the pop. And then after that quickly decaying resonant part, usually there's a part of the sound that sustains for a bit and it rings. And it's really just a lower resonance section of the sound that happens after the initial pop and resonance. So I'll just call that res 2. I'll call this one res 1. And then after the pop and the two kind of resonant decaying components, there's a quick decay, because bass sounds usually decay quite quickly. So I'll put the word decay there. So these are our 4 components of the sound. Some sort of a popping percussive part, 2 resonant sections. The first one a little higher resonant than the other one, the second one, and then a decaying component. And these 4 layers of the sound will directly influence which algorithm we pick on our FM synthesizer. So the second step is to choose the algorithms and operators that we're going to use to program our sound. Rather than immediately running to the DX11 and looking at the front panel to see which algorithm might reflect this type of sound structure, the approach I like to take is to make my own kind of a dream algorithm with as many operators as I want, and then hone it down and chip away until it resembles one of the ones that's available on the DX11. So I'll make a stack of operators for each one of the components of the sound, and then we'll see how close we are to one of the available algorithms. So for the pop, that's got to be some sort of like noisy, percussive type sound. And this is just from experience. I know that if I take an operator that has a feedback loop in it and make the resonance rather high and modulate another simple operator, so it'll just be a sine wave, I can make this turn into kind of percussive sound, like a chiff or a pop. For the resonant type of sound, also just from experience, I know I can do almost the same approach where I have an operator that has a feedback loop modulating another operator. But if I make the feedback loop subtle and kind of extend the envelope a bit, it'll sound like kind of a resonant low-pass filter effect. So the next stack is just a lower intensity resonance, more like a ring. And I can probably get away with just a stack of 2 operators, but without a feedback loop. So this is going to be kind of a duller type of resonant sound. And the last part of the sound, just the decaying part, That can just be a simple sine wave, like a simple operator, and I'll just put a fast decaying envelope on that. So these are my 4 stacks, and as you know, the sound from the last operator in each of the stacks adds together, and that's the output that you hear on the synth. Now there's a problem right away because here I have 7 operators, yet on the DX11 there are a maximum of 4 operators. Even on the DX7 there's only 6 operators, so this wouldn't even be possible on a DX7. So I'm immediately going to have to start chipping away to simplify things. One thing that comes to my attention right away is the initial percussive part of the sound and the initial resonant part of the sound. The stacks are pretty much identical, except maybe for some of the envelopes. So what I can do here is, if I'm careful with the envelope that I used to control the resonance, and I kind of put the resonance or the feedback, and I put the feedback kind of in between the high feedback level I'd want for the percussive pop sound and the medium feedback level that I want for the resonance, I can probably combine these into one. So I'll do this. So I'll just combine those 2 stacks into one similar stack. We solve a problem because we have 5 operators, yet the DX11 only has a maximum of 4. So again, I can kind of do this trick where I can combine different stacks together. If I'm careful with the level of modulation between this top operator and the operator that you're actually going to hear, and this second, well, the third, but this stack here, which is the ringing, the lower resonant component of the sound, I can add the decaying envelope to this stack. So I can probably get rid of this, probably get rid of that decaying, separate decaying stage. As it turns out, this is pretty much identical to algorithm 5. Algorithm 5 on the DX11 actually has the stacks in the other order, but it doesn't really matter which order. So I'm just going to basically flip the stacks. It doesn't really matter which order you draw them in because they both play at the same time. Basically, you know, they play down and then you hear the output. So this is equivalent, putting the feedback on this one instead of this one is the equivalent to the drawing I had just a moment ago. And here I'll remove these legends because they don't really make sense. So this is algorithm 5 on the DX11. The third step is to define the envelopes for the output of each of the operators. Now the algorithm already defines the modulation routing, but the envelopes are what give your patch its characteristic sound. So if you consider this stack of operators here on the left, if you recall, that represents the middle kind of ringing resonant part of the sound and then the final decay. And the top operator here defines the resonance, and the bottom operator, the one you listen to, will define, like, you know, the amplitude contour of what you hear in the output. So for the resonance, we want a relatively fast attack, a nice slow decay down to like kind of a 3/4 level amplitude, and then a quick fade out at the end. Now the envelope for operator 1 should be more punchy, more like the contour of a typical bass sound, because remember, this is the operator that you're actually listening to. So we want an even faster attack, a faster decay, and then we want a longer sustained portion of the envelope, and then a quick release at the end. With the traditional analog synthesizer, when you're dialing in the parameters for envelope shapes, you usually have knobs or faders, and that gives you a visual representation of the actual shape. But with the DX11 and most older digital synthesizers, you just are entering a series of numbers on a little LCD display. So for the DX11, the attack and the decay rates are some number between values of 0 and 31, and that seems kind of like an arbitrary range, but if you know about binary number representation, it makes sense, but that's not important. What's important to know is 0 is the slowest possible slope. Essentially, it'll take about a minute on the DX11. And 31 is the fastest slope, which means it's almost instantaneous. So for the attack and the decay on the resonant part, I'll pick a number for the attack of, say, 25. So that's kind of like a moderately fast attack, and a decay rate of, say, 5, which is a rather slow decay rate. For the output operator, the one you hear, I'll pick, say, the fastest possible attack rate of 31 because we want it to punch on as soon as possible, and also a rather fast decay rate, say 10. The sustain level on the DX11 is represented by a value between 0 and 15. And again, it seems kind of arbitrary, but it makes sense if you consider how that's stored in binary inside the synth. So a value of 0 is a sustained value, the lowest sustained value, and a value of 15 is the highest sustained value. And we'll just pick kind of a number, a moderate number near the middle. We'll just pick 10. For the decay rate, the value ranges between 0 and 15. Again, this makes sense if you think about how the binary digit is stored in the synth. 0 represents the slowest decay rate, and 15 represents the highest decay rate. So for the output envelope, the one you hear, I'm going to pick a value of 10, just kind of moderately in the middle, and we'll make the resonance not decay quite as fast. Now, to simplify things without getting bogged down into too many details, I'm going to set up the envelopes for the second operator stack, the one on the right, to be exactly the same as the envelopes for the first operator stack, the one here on the left. And that makes sense if you consider the type of sound we're trying to set up, because the operator stack on the right also requires a punchy envelope at the beginning and then a slow envelope after that. The punchy part representing the percussive, the pop or the chiff at the beginning of the sound. This comes from this feedback loop, and then a rolling or a sweeping resonant part right after that. So I'll just duplicate the envelopes. Those of you who are familiar with the DX11 may have noticed something fishy about the way I defined the envelopes. I defined all the envelopes to have the traditional attack, decay, sustain, and release shape. But Yamaha on the DX11 incorporates an extra decay stage. So their actual envelope shape is attack. There's a decay stage called Decay 1. And then there's a second decay stage, I'll call that Decay 2. Then there's the sustain stage, and then the release stage. So there's this extra decay stage here to allow more complex envelope shapes. But I've simplified that, and I'm simply going to ignore this second decay stage and set the parameters to 0. So the envelopes that I'm going to program into my DX11 are going to follow the traditional attack, decay, sustain, release shape. Step 4 is to consider the level of feedback. With the DX11, you can only apply feedback to one particular operator, and here it's operator 4. And this feedback loop represents the initial noise component at the beginning of the sound, so that the pop or the chuff. So we want this feedback level to be high enough to give us a noise component right at the beginning, but not so high that it overshadows the resonant component that's going to follow that, which is the decay part of this envelope. The levels on the DX11, the levels that you can apply to a feedback loop range between 0, which is the lowest or no feedback, and 7, which is the highest or maximum feedback. And that's only 8 different levels. So the granularity is pretty low. It's very coarse. So for this value here, we want it high enough that we get noise, but not so high that the noise overshadows the resonance. So I'm just going to pick a number somewhere in the middle, say 4. Finally, the last step, fine-tuning. Here, you just go through all the parameters and tweak them to hone the sound in to exactly what you're looking for. But to do that, we have to start pushing some buttons. So here are my notes from the whiteboard, and I have an overhead camera so that you can see what's on the screen. But before I pick the algorithm, there's a few things that I have to do. First, one of them is initialize the voice. So I'm left with just a simple sine wave. And I'm also going to transpose the entire keyboard down one octave because this is a bass sound, so it's just easier if the keyboard is already transposed down one octave so that it's just easier to play. Now I'll go into the algorithms by pushing the algorithm button, and you can see the algorithm number and a pictorial, and I will scroll through to algorithm 5, and algorithm 5 shows that modulator or operator 2 modulates operator 1, and operator 4 modulates operator 3, and the output that you hear is directly from operators 1 and 3. The pictorial on the LCD is shown horizontally instead of vertically because there just isn't enough space to show it on the LCD. And also it doesn't show which operator has feedback. So if I hit the feedback button, you can see that operator 4 for algorithm 5 is the one with feedback. And the level is set at 0 right now, but we'll get to that in a moment. First, I'm going to hit the operator output level, and it shows the 4 operators, 1, 2, 3, 4, and their relative output levels. The only one that you're listening to now is operator 1, and the level goes from 0 to 99. On the DX11, any value greater than about 90 starts to sound overdriven. And once you get to the top end, like 97, 98, 99, it will sound distorted. And just from experience, I know a good level to use is about 95 to begin with. So the 2 operators that you hear directly, 1 and 3, I will set their levels to 95. So this is 2 sine waves heard simultaneously. Now I'll set the modulating operators, which are operators 2 and 4. Rather than 95, I'll set these at 75 because you want them loud enough to hear the FM effect, but you don't want them to be overdriven. And by the way, I'm using the data slider here to set the coarse value and then the up and down buttons to set the final value. So now you can start to hear the FM effect come in. So this is how we'll start. So there are no dynamics to the sound right now, it's just these fixed output levels. So the next thing is to set the frequency ratios. So I'll hit the coarse frequency button, and if I hit it multiple times, you'll see it cycles through the 4 operators. Operator 1, 2, 3, and 4. And the ratios are all set to 1. And what that means is it just plays the fundamental, so the pitch of whatever key you're pressing down. But because this is a bass sound, we'll take operator 1 and we'll drop it down an octave. Now that means a ratio of 0.5 or 1/2, because as you know, if you go down an octave, you halve the frequency. So 1/2 or 0.5 means down an octave. So now you can hear kind of a beefy low end coming out. I'll hit the coarse frequency button again, and we'll get to operator 2. That's the modulating operator for operator 1, so the one that makes the harmonics. And I'll drop that down an octave as well. So now you can hear it starting to really fill up the low end. Then we'll go to operator 3, so that's the second one that you can actually hear. Now, the stack, the operator stack where operator 3 is the one that's going to make the sharp pop or the sharp transient at the beginning. And you don't want to drop it down an octave as well, because if all of the operators are dropped down an octave, the sound is going to start to be quite muddy. So I'm actually going to raise this one up an octave. And I'll take operator 4, which is the one with feedback and modulates operator 3. I'm going to drop that down an octave. There we go. So most of the operators have been dropped down an octave, but I left operator 3 up an octave so that we still have kind of like a bright defining top end of the sound. Otherwise it would just be mud. Okay, now we can go on to the envelope generators. So if I hit the envelope generator rate button, I will cycle through all of the rate parameters, the attack and decay and release rate parameters for the envelope. So if I push it once, I see AR, attack rate, and there's a different attack rate for each of the 4 operators. 31 being the fastest, 0 being the slowest. So in the DX11 manual, they don't actually tell you how fast the rates are for each numerical value, but I know about 31, or the fastest, is just under a millisecond, and 1 or 0 is about 10 or 20 seconds. So we want 1 and 3, the operators you actually hear, we want them to be as fast as possible, but the operators that do the modulation or create the harmonics, I want them to lag a bit. So I'm going to set them, operators 2 and 4, I'm going to set them down to about 25. And this will be kind of a common theme you see, where the operators that you hear get the same numerical value, in this case 31 for the attack rate, and the modulating operators also get the same numerical value for some parameter. Here, again, the attack rate for the envelope. And that's just to get you into the ballpark. It's a good rule of thumb, and it also makes it easier to keep everything in your head, because rather than worrying about 4 numbers, you only have to worry about 2. So now I'll hit the rate button again, and now we get the decay rate, or the decay 1 rate. The envelopes in the DX11 have 2 decay stages. We're only going to use the first one. We'll ignore the second one. So it'll basically act as an attack, decay, sustained release envelope, just a regular one. So we want the decay rate to be rather slow. So we picked 10 approximately for 1 and 3. Those are the operators that you actually hear. And again, the modulating operators, we want them to lag a bit, so I'll set them at 5, so considerably slower than that. And now I will, so we've done the attack, the decay, now I'll hit the level button. So this is essentially the sustain level. We want the operators that you can hear to drop down a little bit from the maximum. So the maximum here is 15. So we'll make 1 and 3 go down to about 12. For the modulating oscillators, 2 and 4, remember those are the ones that are making the harmonics, we want them to drop down the sustain level to be quite a bit lower than that, because we don't want all these harmonics in the kind of the steady constant part of the sound. We want them to drop down quite low, or the sound will just be too busy, and it'll be too heavy for a mix if you're actually using it in a song. So rather than only dropping it down to 12 or something, let's drop it all the way down to, say, 8. Okay, now we'll go back to the rates. Attack, decay 1, decay 2 we're ignoring. I'm hitting the rate button again, the release rate. So 15 is the fastest release rate, so that's an immediate cutoff. We don't want that. We want something that's fast, because it's a bass sound, but not too fast. So we'll take 1 and 3. Those are the operators you can hear, and we'll set them to 10. We can tweak these values later. And just like before, 2 and 4, we'll make those a little slower. They're actually going to get cut off from the ones you can hear from 1 and 3. We're going to set them low as well, say at about 5. So now we've set the attack, sustain, attack, decay, sustain, and release stages of the envelope. So let's see what we have. Here, let me hit a higher note. So I'm only listening to the envelope here, the dynamics. You can hear it attacks and then goes down like a bass sound would. And the decay is quick, but not instantaneous. Okay, this is okay. It sounds kind of like a bass sound, but it's really boring and there are practically no harmonics. So let's go back to the operator output level. So I hit the operator output level button. Remember, we set the output levels for operators 2 and 4 to be 75 or quite low. So this is where the finesse of the sound starts to come in. I'm going to bump up the first modulating operator for the first operator stack. And you'll hear the harmonics start to come in. There, you can hear them coming in. And you can go right overboard. Let's max it out. It starts to get a bit distorted. It kind of sounds like a distorted bell sound or something. And what you want to do is play the sound over its entire range and find a level that is where you can hear the effect you're looking for, but it's good over the entire range and defined both at the top and the bottom. That's really nice in the low end and still good on the top end, so I'm going to keep this at 85. Now let's go to the other modulating operator, operator 4. This one's a little different. Let me hit the feedback button. Remember, this is the one with feedback, which is currently at 0, but the level is still moderate, or 75. So there's a kind of a yin-yang thing that happens with the operators that have the feedback loop. You want to bump the feedback up to get the effect of the feedback. In this case, it's going to be that thwack or that ping right at the beginning of the sound. But you don't want it so high that it's going to distort or make noise. Similarly, you want the actual level of the operator to be high so that you get the harmonic content. But if you make both the feedback and the output level high, you're just going to end up with noise. So first, the feedback is a rather coarse setting. It only goes up to 7, so we only have 7 possibilities. Let's put it at 3, so something very moderate, and then we'll start bumping up the output level. Let's see what happens. Well, it's definitely adding lots of twang. Okay, let's increase the feedback. Whoa, okay, now that's getting more interesting. Okay, now we're starting to get that. Okay, now we're into noise territory. This is, by the way, how you make snares. We're not trying to make a snare. So somewhere around 5, maybe a bit more or less, is a good level. So there's a good feedback level. So let's go back to the actual output level and drop it down, maybe close to where operator 2 is. Again, it's that rule of thumb. Take the modulating operators and make your settings the same, and that'll get you in the ballpark. Now let's increase the feedback a bit. That's good. Pretty good. Still a bit twangy, so let's lower the level a bit more. That's a little dull. That's good. That's pretty good. I think we're in the ballpark there. So at this point, what I'm going to do is go back to the envelope generators, and I'm just going to tweak the values a little bit. I'll stay close to where they are now, but I'll tweak them up and down a little bit just to bring out the envelope for those modulating oscillators to get that nice long resonant effect. So I'm going to try to maximize the resonant effect by playing with the envelopes a bit. So give me a moment and I'll be right back. At this point, I've made some minor adjustments to the envelopes just to bring out that nice resonant sweep. The changes were very minor. For example, on the attack rate, if you remember, operators 2 and 4 had an attack rate of 25. It's now 26. There's a few other slight changes that I made, but very minor, just to make that nice sweeping resonant sound. So there's one other tweak you can do to beef up the sound even more on the DX11. You may be able to do it on your FM synth. Some of them are a little different, and that is to detune each of the operators by just a bit. So if I hit the detune button, you'll see there's a detune setting for the 4 operators, 1, 2, 3, 4, and they're all set at 0. By detuning, I'm talking only a few cents. When we set the coarse frequency, that was, bumping things up and down an octave. I'm talking about just a few cents of detuning. And the idea is you take the 2 operator stacks and you detune one of them flat a bit and the other one sharp a bit. And what it does is it gives a slight chorus effect and broadens out the sound. So, for example, for operator 1, I'll detune it down 3 cents flat. And operator 3, these are the ones you can hear, remember, 1 and 3. I'm going to make it 3 cents sharp. And then for the modulating oscillators 2 and 4, I'm going to make them 2 cents flat and 2 cents sharp. So this is what it sounds like now. It's a very subtle change. So what I'll do is I'll go into the compare edit mode to show you what it's like with and without the detuning. This E, by the way, means edit mode, and if I hit the compare edit switch, it will go to the previous setting that I just had it so we can do a comparison. So first I'll play it with the detuning, and now without the detuning. Now I'll do that again in faster succession without talking in between. So first with and then without detuning. So as you can tell, detuning the operators a little bit broadens out the sound and gives you a nice chorus effect. Well, that's it for this video. Thanks for watching.